Good morning, everyone. In the last session, we discussed about the multi-threading concepts here. So the multi-threading, the different concepts we identified in the last session. So today we are going to discuss about the one of the another important concept to call enumerations and autoboxing. Okay. So first we'll start with the enumeration. So basically, enumeration is also one of it's similar to the final keyboard. So whenever we are adding the final keyboard, what happens internally? Only so one time we are going to have the behavior to initialize the value, and once you initialize the value, we cannot modify the those information. It's like we'll call it as a constants. Getting the point. So we'll call it as a constants. So same way, so we are going to write with help of this particular enumeration, and enumeration is introduced from the 1.5 onwards here. Okay. So we'll see how this particular enumeration will contain. And basically, not only the one case, like we are going to write list of enums here. So whenever we are trying to define the enumeration, we are going to define the list of enums here. Okay. So each enum will contain internally similar to the final keyword behavior. So we'll understand here how this particular enumeration is going to work. Okay. So how we are going to define the enumeration with help of this particular enum here. With help of this particular enum. So now what I will do, I'm going to create a one more package here. So I will delete this particular package I'm going to delete, and here I will try to come up with one more package, and here I'm not adding the controller. So this is basically, so now you can see enum is a keyword, so we cannot use enum as a name of the package name. So I modified with the capital E. Now we are able to create the package name, and internally I'm trying to create a enum. It is basically enum is also similar to the class, but internally it's contain the list of constants here. So that constants how we are going to define with help of this particular enum keyword. Okay. So what is the name of this particular enum? Okay. Otherwise, what we will do, this is the level I'm trying to create a enum level. Now observe carefully what I'm doing. I'm trying to create this particular enum. Observe how I'm trying to create it. So public name of this keyword called enum, and the name of the enum name. So what is the name of the enum name? That is called level. So what you need to understand basically here, enum instead of enum, what we will write basically, it's a class or interface. But this is the another keyword we are discussing here, something like enum. And inside this particular enum, what we will do, we'll try to create a list of, we'll try to create the list of constants here. So how we are going to create this particular list of keywords? So now observe one keyword I'm trying to write. So one constant I'm defining here, not a keyword here. One constant I'm defining, and so this is the another constant here. Okay. So now you can see how many constants I defined here. Three constants. So each constant internally, it's going to work as a the final behavior. So how the final behavior we identified whenever we are trying to discuss here, the same way this particular constant is going to define here. Okay, this is important, we need to understand here. So once we define this particular constants here, what happens internally? Now we need to understand here how this particular constants we can use here. How we can use this particular constants here. So if we observe, basically how many constants we define here? Three constants. First one is low, second one is medium, and third one is high. Okay, and using this particular enum, we are not going to create any object here. So using this particular enum, we are not going to create any object. This is important, we need to understand here. So what we will do basically, if I want to get an object here, we are going to call level dot low, level dot low, or level dot high, or level dot medium. With help of this, basically enum internally how it is working based on this particular enum name. Enum's constants internally we are able to load with help of this particular name of the enum class. name of the this particular enum we are trying to load here. Okay, so observe carefully. So how we can write the simple example here. So we define this particular enum here. Now I'm trying to create a enum demo. So here only inside this particular enum package, I'm going to create a enum demo, and enum demo will contain this particular main method. Okay, so observe what I'm trying to write here. Here I'm trying to define level. Okay, so this particular level, what is the level? Basically it is a enum type. Okay, after this, now what I'm doing here, so LEA is equals to level dot, how many we are having here? 3, the constants we are having. So you can write anything here. So I'm trying to define as a low. So now what you understand here, if I want to load this particular constants here, what I'm doing here, I'm trying to use this particular level dot low. Level is a one of the our enum, and with the help of this particular enum, I'm trying to load one constant. And later what I will do, so if I want to print this particular enum here, simply value of LA. Okay, so value of LA. Now later what I'm doing is I'm trying to print this. So value of this particular LA, what is the value we are getting here? Something like low here. Otherwise, what we can do, value of level. Okay, so this is another way of writing this particular message here. Now you can see value of this particular level. What is the level of this? It is a low level. Carrying the pin. So this is the way we can load the value. And another important information, now you can see I'm making the condition here. So how I'm making the condition here? Now observe carefully. LA equals to, you can make any condition here. You can make any condition. So level dot, something like you can make as a high. So when we are trying to modify the level, if the level is equals to high, now what we will do? We'll try to print this message here. We'll try to print inside this particular if condition. So what we can print here? Something like LA. But here, what we need to understand here, this particular statement is not going to print. So why this particular statement is not going to print? Because what is the value we are loading? So we are trying to load the low value. But what we are trying to check the condition? We are trying to check the condition of high value. Getting the point? This is important here. Now, if I'm going to run this example, observe carefully. So still only one statement is printing. If I'm going to modify this, so for example, if I modify to this particular statement to high, and if I'm trying to print the same example here, observe carefully. First one is printing high, second one is printing inside this particular condition here, inside this particular condition. Okay, so these are all the two important information we need to understand. So this is the simple way of loading the value, and the same value we can load inside the conditions here. Okay, along with this, now what we can do, we can make the particular switch cases also. So how I'm trying to write the switch cases? Switch cases I'm defining. Here I'm trying to write LE. LE is the expression that we are already identified. Now what you need to understand here? So we need to understand the conditions like case statements here. So how many statements we can write here? So we can write here how many constants we are having initially. So we are having 3 constants here. So first the constants I'm defining low. Getting the point. The first constants I'm defining as a low, and so low constants here, and I want to use break here. Case here, second one is high, Okay, so something like low, high, and medium. Getting the point? This is important here. So this is the way we can check this particular constants here. And now, so another case. Okay, so if these three are not satisfied, if three cases are not satisfied, now what we'll do, we'll try to move on to this particular default case here. Okay, so let's run this examples. Now what we are understanding is the high related constants is satisfying here. So this particular case is satisfying here. Okay, because what is the value we are trying to load here? We are trying to load this particular case level as a high value. Okay, this is a important example we are discussing because in the real time scenarios we are going to write multiple cases here. But what we are doing is, so we are going to create a enum like this, public enum. So different names we are going to make it, and based on our availability, we'll try to make as a different here. Okay. So now observe, if you are trying to create a one enum like save, update, delete, and load related. So this is the different enum we can write, and whenever we are trying to communicate with whenever you are trying to communicate with the different applications here. So based on that our operations, we can write the different enums here. Okay, this is important here. But what you are doing here, with help of this particular enum, whatever the enum type you are having, name of the enum. Okay, name of the enum. Using this particular name of the enum, we are trying to load the constants here. Okay, so now what you understand internally, it is having the behavior call final and static here. The static behavior basically what it will do, based on this particular name of the class name or any name, the enum type something, we are going to load the information here. So this is important here because if it is a class, the name of the class name, we are trying to load the constructor method something. But if it is a enum, what we are doing is with the help of this particular enum type, we are trying to load the constants here. Okay, this is important. We need to understand. And inside this particular enum, we are having two methods here. So first method we can load the all the values, and the second method we can load the value of here. Okay, so if we observe carefully how we can load this particular all the values and value of method. So now what you need to understand after this particular case here level dot values. Now you can see this is the values method we are having. Each enum will contain this particular values method or value of method. Okay, so values I'm defining. So once I define this particular values, basically it's returning list of values. It is returning list of values. So now whenever you're calling this particular values method, what happens internally? How many constants we are having inside this particular level? How many constants we are having inside this particular level? All the constants will load. Getting the point? All the constants will load here. So now you can see here I'm going to make loop here. Getting the point? So here I'm going to make loop here. So what is the type we are going to have basically here? The type basically here, what is the enum type here level. And so now here I'm going to print this particular L. Whenever I'm trying to print this particular L, now what you need to understand basically? What happens internally only? One statement we are printing. Okay. Sorry, I define inside this particular switch case here. come out to this, and you can print this because we define inside the switch cases here. So because of that, it is not matching here. Now you can see low, medium, high. Getting the point. How many constants we are having inside this particular enum? So all the constants we can load with help of this particular values method. So again, how I'm trying to load this particular values method with help of this particular name of the enum type here. Getting the point. This is important. We need to understand here. Okay, so what you need to understand basically here, you need to understand this particular values method. How we are loading this particular values method with help of this particular enum type here. Okay, so if you see all the information is either we are trying to load the constant with help of the enum type only, and the same way the values method also again I'm trying to load with help of this particular enum type here. Okay, so here we are not creating any object. Getting the point. We are not creating any object of this particular enum type here. So if you say another method, so how we can load another method? Now observe carefully. To load this particular another method, we'll try to use this level dot value of method. So what we are going to pass this particular value of method here. The value of method is expecting string here. Now you can pass this something like I'm passing as a low. Whenever I'm trying to pass as a low, so what is the value it is going to return? Basically, it will return the enum type here. Now you can see, so we are getting one of the enum type called level. Okay, so now what you need to understand here, if I'm going to print this level, so now we need to understand the last println statement. We need to understand the last println statement. What is the value we are going to get here? So now no enum constant. Now what you need to understand basically here, whatever the enum constant we are trying to load, so that is not available. Getting the point. So what is the enum constant we are having basically? Here we are having low, but how this particular low is having? How this particular low, the low is not having it. So we need to modify something like here. Okay. Again, if I'm going to run this, now you need to understand here, it is printing. Now what do you understand here? Whenever we are trying to load this particular value of, this is important here. The value of basically what it will do, it will try to take the string as a parameter. But inside the string, so you need to provide the exactly the constraint name here. If you are providing small cases or capital cases, so you will get the whatever the exception just now we identified here. Getting the point. We need to provide the same constraint name. If it is in the lowercase, we need to add in the lowercase. If it is in the uppercase, we need to add in the uppercase. So if you miss the case here, you will not get the expected the enum constants object information here. So here we are trying to load all the enum types, and I'm trying to print. So what I'm getting is the last println statement I'm getting as a low. How I'm loading? With help of this particular value of. So this is the way of loading the single constant, and if I want to load all the constants here, so we can go for the values method. So this is the differences between value of and value values method. Okay, now so what I want to provide another important information here, basically whatever the enumerations we are discussing here, these are all the class types here. Getting the point. Basically, all the Java enumerations internally, it is a class type here. So basically, even if it is a class type, we are not going to create an object of this particular enum type using the new operator here. Getting the point. So other than this particular object creation, so everything we can define here. So now what you understand basically here? So here we can go for this particular constructors. Getting the point. So we can define any method if you want to define, but only one thing we are not going to provide. We are not going to create object of this particular enum here. Okay. So using this particular new keyword, we are not going to create an object. But how we can define the constructor here? How we can define the constructor? So now observe carefully. So what is the parameter I'm going to use? and here private into price I'm defining. Okay, so private into price I'm defining. So once we define this particular price here, now what you need to understand here, level which is expecting, getting the point. This is the price here. Okay, and this dot price is equals to price here. Okay, now so whenever I'm trying to add this, whenever I'm trying to add a constructor, getting the point. This is the, we'll call it as a constructor. Okay, along with this particular constructor, now what I'm doing is I'm trying to return get price here. Internally we can return the price. So observe carefully. Now what I'm doing here, I'm trying to create a constructor, and after creating this particular constructor, now what I'm doing here, I'm trying to add a method here. So this is, we are going to call it as a constructor, and this we'll call it as a method here. Okay, we are adding the method and constructor, but why I'm getting this error? So whenever you're defining the constructor, the each constant should pass the value. Each constant should pass the value. So for example, this particular low constructor, like low constant here, I am trying to provide the something like 45, something like 45, and the medium I'm giving as a something like a 65, and the high I'm giving as a 95. So now you can see, whenever you are defining the constructor, if this particular constructor is expecting parameter, if this particular constructor is expecting parameter, now how I'm passing the value? Because we are not going to create an object of this particular constraint here. How we are passing the values to this particular constructor? Whenever we are defining any constructor, after this particular constraint here, we are going to provide the value. This particular 45 value, it is going to call internally, this is the constructor, and we can use this particular method to return. So simple example, instead of printing this level, now you can see we can call the get price method. So earlier I did not get this information, but whenever you're adding this particular constructor, now you are getting these many informations here. So you are getting the name, okay, you are getting an ordinal, and now you can see values and weight. These are all the comparative equals. All information we are getting. So observe carefully one more time. I'm trying to comment out these two sections here. Okay, so here I'm trying to comment out these two sections. I will try to remove right now whatever the values we are having. Okay, so now I'm going back to the earlier what we implemented here. Now if I'm going to call it level dot, now what I'm getting here, now you can see, so here I'm not getting the particular get price method. I'm not getting any price here. So for example, if I'm going to print here, so here also we are getting all the information. Now what you understand, you can see white method, notify, and notify all method, some toString method, get class. These are all coming from the object class here. These are all coming from this particular object class here. So now what you understand here, so whatever the enum we are going to create, so that is by default is extending from the object class. Okay, so whatever the functionality we are having with help of this particular class, the same functionality we are getting with this particular enum, but only one thing, we are not going to create an object of this particular enum type here. Okay, this is very important, we need to understand. And whenever I'm trying to print this, level dot get price here. Now because of this particular constant, what is the constant we are loading low, and the price I'm trying to print, that is called 45 I'm getting. Okay, so this is the way of writing this particular constructor and this particular method. But the constructor value, again we are going to provide for this particular each constraint here. So you can take any parameters here. So for example, if I'm going to take this into price gamma string, now you can see whenever you're adding the parameter, so again this particular constraint is giving me an error. Why it is giving me an error? Because internally this particular each constraint, it's going to call this particular constructor here. Okay, how many constructor you want you can create, but what we need to do, we need to write the parameter to the each constraint here. We need to write the parameter to this particular each constraint here. So this is very important, we need to understand here. Okay, so any questions regarding this particular simple example what we are discussing inside this particular constraints here?
Sir, I have one question. Can we go the Enum demo class?
Okay.
Yes, here. Sir, can you please explain this line number 28 again?
See, 28 basically, now what I am doing here, I am trying to call value of. So here I am trying to load the single enum constants here. Using this values method, I am trying to load list of the constants which are available inside this particular level enum. So you can see, so I am trying to provide the return type of this. Let me provide so the return type. Okay, so here I will use level dot values. Now you can see the second one, it is trying to return array type here. So here you can see it is returning array type. Whenever it is returning array type, basically it is a list of constants here. Okay, it will return by the this particular values method will return list of constants here, and the value of basically it will return single constant here. Okay, it's like a single object. So this method will return the single object, and this method will return the multiple objects here. Okay. So any questions? So along with this particular price here, now what is another method we can use? So this is nothing but ordinal. The ordinal method, what it will do, now understand here. Whenever I'm trying to run this example, it is returning 0. So it is returning 0. So here, along with this particular L, here you can see name of this particular constants I'm printing, and so I'm giving some space, and L dot ordinal I'm printing. So you can observe I'm trying to print inside this particular loop. So what it will do, it will try to print the name of this particular constants along with the position. Getting the point? Along with this particular position. Now you can see low is in the 0 position, and medium is in the 1 position, and high is in the second position. Getting the point? Now what is the name is doing basically, it is trying to load the, like it is trying to print the name of the constraint here, and along with the position of this particular constraint here. Getting the point? So this is the way the methods are available inside this particular constraints here. Okay, then the remaining method, those are all the methods are coming from the object class and comparator related examples here. And here what I want to provide the another important information. So this particular enums, they are going to extend from the this particular the type here. Let me provide the type enumerations. So it is not not enumeration. So basically enum. So this is the enum we need to understand. Now you can see basically it is a abstract class. Okay, enum is a abstract class, and whatever the enums we are going to create. So for example, here we created this particular level. Okay, Now, what we need to understand, so this particular level enum by default, it is extending from this particular enum, whatever the abstract class I'm trying to show here, whatever this particular abstract class I'm trying to show, all the enums by default, it will extend from this particular class. Now you can see the name we are having here and ordinal we are having here. Okay, so along with this particular name and ordinal, now you can see it is a one constructor. They are expecting name and ordinal and toString method, equals method, hash code method, and clone method, comparative method. So from if we observe all the information, so wherever I'm trying to call this particular enum demo, whenever I'm trying to call this L dot. Now you can see the name method we have identified ordinal toString equals get class and notify wait getting the print. So these are all the methods from where we are getting. Some of the method we are getting from this particular enum and some of the methods we are going to get from the our object class here. So now what you understand basically here? What you need to understand? Whatever the enum we are defining, the enum by default it is extending from this particular enum, one of the abstract class here. Getting the pen. So now, any questions regarding whatever the method I shown here? So now it is understand from where these methods are loading here. Any questions?
Sir, why we are making class enum?
So it is not a class. It is a different type. How we use the class interface is something. So we have a different the keyword we are having like a enum. So using this particular enum, what we are doing basically, we are going to define the constant. Like these are all the static ones. So once you define, it is not going to modify. So it is a common reusable purpose.
Okay.
So how we are defining the final constant? Same way, we are going to write with help of this particular constant. But once we define this particular constant, we can write the multiple constructors, multiple methods we can write. Okay, so along with that we can make the different conditions. So most of the time basically the simple example, whenever you are trying to work with a REST APIs example, so each and every request we can easily understand by this particular constants, like we can define the all the constants informations here. We can define all the constants information here, like a save, update, delete something, and we can make the conditions and we can call the appropriate methods here. Okay, so the simple example here, if you see the this particular LE based on our requirement, this LE is going to modify. If you are trying to save here, this expression will be save. So the appropriate case statement is going to satisfy. Okay, for other cases, it is become update here. Okay, some other cases it is become loading. Okay, that information we are going to pass request here. Whenever we are trying to hit this particular application, we'll try to send in a request information. So from the request information, we can extract this particular expression information and we can call appropriate case statement. So otherwise, you can make the if conditions. Okay, if you are not interested in this particular cases, you can make the if conditions. Along with this, now what you need to understand basically, along with this particular save update, we have a different. For example, if you are trying to work with a banking related application, well, now what you will do, we'll try the different types of applications like saving account, current account, or some any joint accounts. Getting the point? We have a different types of accounts here. So those account informations also we can make a enum constants and we can make the different conditions based on our requirement. Getting the point? So each and every application, so its enum constants will be different. We are going to write so lot of enum constants here. Okay, so some cases like renaming the object information, or so if it is a new object, we are going to insert one more object. Getting the point? Insert, rename, or delete. Getting the point? So based on our application requirement, we are going to write the different constants here. But here, what you need to understand here, so how in the which scenario we can go for the enum constants and what are all the constants we need to define. So that you need to understand very carefully. Getting the point? So now we can see another important example, comparative method. So from where this particular comparative method is coming, because of this particular comparable, we are getting the one method called comparative. Here you can see comparative method. Okay, so what it will do, we'll discuss this particular comparative related example once you are moving into the collection related. But now observe. So here you can see the simple value. It is returning the integer value, and here you can read this parameters. So 0. Okay, so it is a negative integer or 0 or positive integer. So as this particular object, if it is a less than, now what it will do, it will return this particular negative integer. If it is equal, it will return the 0 value, or if it is a greater than the specified value, it will return the positive integer value. Now what we can understand, if it is a greater than value, whatever the value we are providing, if it is a greater than, we are going to get positive values. So positive values or negative values are 0. Okay. Now same example I'm going to add here. And here L dot comparative method, we need to provide, I'm providing LE, and I'm going to check greater than 0. I'm trying to check this particular greater than 0. So basically this greater than 0, now it will return condition here. So it will return true or false here. Here I'm going to make this particular condition. If it is greater than 0, now what we can do, you can print this particular L here. And inside comparative method. So just I'm providing how we can use this particular comparative method. Now understand here, any example we are getting? No. So we are not getting any example with help of this particular message here. Now maybe all are returning less than. So now I'm trying to converting into the less than here. Now you can see inside this comparator low I'm getting and medium I'm getting. I'm not getting high. Getting the point? I'm not getting high. So what is the LE value we are having here? The LE we are having high only. Okay, this is the bigger value we are having, and only these two are the lower values. What are the two lower values? First one is low and second one is medium. Okay, so this is the way we can check one condition, and one more condition. Now what I'm doing is I'm going to check here equals to 0. Okay, so compared to equals to. So now I'm going to run one more time. Now you can see, so inside this particular compare to equals to, the method we are calling as a high. Now what you understand here, whatever this particular L we are passing here, and it is matching with this particular LE, both are equal values. And these two, this particular condition is printing two times, because these two are the lower values of this particular height. First one is low I'm getting, and the second one is medium. Getting the point? So this is the way of using this particular compare to. So what we understand here, we can check the condition less than, greater than, and equal. So based on this particular three conditions, we can go for this particular compare to here. Any questions regarding this particular compare to? Okay, if not sorry, if you don't have anything, now I'm going to write one more enum. So now we'll understand here what exactly this particular enum will do. Okay, so let's see how we can define this particular enum here. So this is the one more another enum I'm trying to use, something like answers. Okay, the name of the enum what I'm trying to write here, answers. Inside this particular answers, I'm going to use something like no, yes, and maybe, later, and soon. Okay, so these are all the different enums I'm using. Okay, now I'm going to use a different enum main example here. So question enum. This is the question enum I'm trying to define here. And after this, now what I'm doing here basically here, I'm trying to create this particular, I'm trying to create this particular one method. This method will return the value here. So this method answers, the method will return. Name of the method I'm having ask here, and what it will do. Okay, so I'm making the static here, and I'm using one random class here. So random is equals to new random, and what I will do inside this particular random, sorry, okay, so copy this. So random dot next enter. Okay, so this method will return the integer value. Same way we are having different method, it will try to return the appropriate data type value. So you can go for the float, double, long, something. Okay, so we are expecting integer value. Now what I will do, and this particular integer value, I will try to store into this particular RAN. Okay, and later, now what I'm doing here. So I'm making the conditions. If this particular, the RAN less than 15. If this particular RAN, if it is a less than 15% here, now what I'm doing is, I'm trying to provide return answers dot maybe something. You can make anything here. Just for our understanding, I'm trying to make this section, and I'm making else if section here. Observe carefully. So this particular section, if it is a 30%, and now what I'm doing is, I'm trying to return here answers dot. So what we can provide, something like no. So same way you can make multiple conditions. So if it is 30, so what I'm trying to provide, something like 45. Answers dot something like what we can provide here. We can provide as a yes here. Okay, random value. And finally, we can go for the else section. Simply answers dot never. And what I will do here, I will try to call the ask method. This ask method, what is the value it will return here? Answer here. So we have a two ways. Instead of creating this particular object here, directly print this information inside this particular method here. This is the one way of writing. Whenever you are not interested to with the return value, so it is returning never. If I'm going to run multiple times, so maybe it is returning. And if I'm going to run, because we are using random value, based on this particular random value, what happens internally? So the value may be different here. The value may be each and every time we are going to get as a different value. So in our case, only it is returning two times, like two types of values here, never and maybe. But sometimes it may satisfy the different kinds of this particular operations here. Getting the point. This is we need to understand the simple example. This is another the enum we created. So with help of this particular different constants here, and I'm using if condition. So you can use the same information inside the switch cases also. Okay, this is important one. Any questions so regarding this particular answers enum? Okay, so if you don't have, now I'm moving into the another important concept to call type conversion. So or we can call it as a the type wrapper. Basically, we identified the primitive type data types here. What are the primitive data type we are having here? Now the primitive data type basically these are the int, long, float and double, char, boolean. We identified short byte. These are all comes under the primitive data types here. The primitive data type, the first character is small letter. Whatever the first character we are having, small letter. So if you see int, I is a small letter. Okay, float, F is a small letter. Double, D is a small letter. Getting the point. But same way, we are having vapor classes here. So what are all the vapor classes we are having? First one is integer. Integer, inside this particular integer, I is a capital letter because it is a object here. Because it is a the class we created. So using this particular class, we can go for the object. And now, now what you need to understand basically here, what you need to understand basically. So whatever the vapor classes I'm going to discuss here, all are object type here. Now you can see integer is one type here. Now you can see, so this is basically finally class. What is the name of the class we are having? Integer, and is extending from the number class, and it is implementing from the particular comparable here. Okay, so just now we discussed about this particular comparable. Internally, it is having only one method that is called comparative method. The comparative method, what exactly it is doing internally? It will return the negative values, 0 and positive values. Getting the point. This is we identified. But come back to here, what is a number class? So basically, how many what are all the data types we have discussed in the previous example? Some data types will return the like it will try to accept the number values, and some data types will not accept the number values. So for example, so now we identified integer. Internally, it is extending this particular number. Okay, another type I'm going to return here something like a float I'm defining. Okay, the float you can see this is coming from the integer java.lang package here. So this is also extending from this particular number. Okay, now what about this particular double? Double. So double is also coming from the same package. Sorry, I open the different class here. This is the double here. Now you can see double is also extending from the number. So because it is also it will also accept the values called number. Now if I'm going to open this like a boolean, let me make this capital. This particular boolean is not extending any class. Whatever the boolean class we are defining, it is not extending any class. Now you can see what it is doing internally. It is trying to return this particular false, and it is returning true. Only two objects, because we already discussed here the boolean data type will store only will store only two values here, either true or false here. So another important we need to understand something like character. Character. So we discuss about the char. Char is a primitive data type. Character is a wrapper class because it is an object here. Now you can see we created the character class and is implemented from the serializable comparable. Okay, we'll discuss about this particular serializable later. Now we already identified the comparable, what exactly it will do. And now whatever the classes are I opened just now, all the classes are having final behavior. This is important here. Now you can see boolean is also having final, getting the point, and character is also having final, and double is also having final, right? Float is also having final. Now whatever the wrapper classes we are having, those classes we cannot extend here. Those classes we cannot extend here. So for example, so here I am defining question enum. If I am going to extend with integer. Now you can see what happening internally. You can read this error. The type question enum cannot subclass of final class. Cannot subclass of this particular final class here. Okay. What is our final class we are having? Something like here integer here. Getting the point. So we cannot extend any final classes here. This is important here. Now we identified the what are all the wrapper classes we are having. Now the question here, how we can convert primitive type to wrapper class and wrapper class to primitive type here. Getting the point. Now what we need to understand here, so each class can have a different method. So if I'm going to open this integer, now if I'm going to show you the method, so what are all the methods we are having right now? What are all the method we are having? We can see, so you can see parse into method is expecting string. It will convert into this particular integer. Okay. And value of. So value of also internally is expecting the string and it will try to converting into this particular integer. Okay. So we have some methods internally. Each class will contain the same method. It will try to convert into the specified object type here. Getting the point. And so byte value into value is on the appropriate wrapper class. We'll have a method here. Something now you can see into value. Somewhere you will find out the into value where it is. Into value. Now you can see what exactly it is returning this. Whenever you are calling this particular into value, now you can see it is returning primitive type here. It is returning primitive type. Now you can see it, this long is also one primitive type, int is also one primitive type, short is also one primitive type. Now same way you will have byte is also some primitive type. But now you can see for short and byte, for short and byte we are doing explicit typecasting. For int we are not doing here. Getting the point. So this is important here. So what is the value type basically? Now it is basically it is a int type. Now whenever we are using this particular int type, whenever you are trying to converting into byte or short here, we are making explicitly type conversion. For into long, we are not making here. For into long, we are not making any type conversion. So same way, so observe carefully one of the another important concept called number class. What are all the methods we are having? And now you can see it is basically abstract class. Okay. So what is the abstract class we are having? Number. The number abstract class is extended with all the almost all the wrapper classes because integer related classes, long, float, double, byte, short. Okay, these are all the classes is extended by the particular number class, and all the methods are override into the each and every subclasses here. So now you can see short value, byte value, long value, int value, double value. Okay, all the values we are having here. All the values we are having here. Okay, this is important. We need to understand. So the abstract classes has having the all the method declarations, and those methods are implemented inside this particular each and every class. So what happens if I'm going to provide a float value? So what the float value, what is returning internally, it is converting float. And the same way, the integer value we are converting into this particular double type here. Okay, so this is internally doing the type conversion. It is internally, it is doing the type conversion here. Okay, this is important. We need to understand the each and every method, how it's coming from. Same way, so we'll move on to the auto boxing. So before moving on to this particular auto boxing here, where is our question in? Yeah, here. Now, understand carefully. Here I'm not writing this. So here we are going to come up with the upper classes. Integer, I is equals to new integer. What I'm doing is, I'm trying to provide the value. I'm giving 100 value. Okay. So why I'm getting this line here? Why I'm getting this particular line? Because it is deprecated. From which version onwards it is deprecated, this constructor. So with that section we'll see. But now understand here, once we define this particular I, now what I am doing is I dot into value. I dot into value. So this into value converting into the primitive type value. Getting the point? It is converting into a primitive type. So from this particular primitive value, again, we can convert it into this particular object here. So how I am converting? Now basically 100 is a value. 100 is a value. The value I'm trying to converting into primitive type. So basically it is a object type, and from the object type, whatever the value we are getting, I'm trying to converting into this particular primitive type here. Okay, this is a one side operations. So if I'm going to print this particular value, what is the value we'll get here? Something like 100. Something like 100 we'll get it here. Okay, so we are getting 100. Now same thing, how we can convert primitive type into vapor. How we can convert primitive type into vapor. Something like a VAL. The VAL I'm giving as a 200. So whenever I'm giving as a 200, so instead of this particular 100, I'm going to pass as a 200, the value. Basically, val is a primitive data type here. The primitive data type basically, now what I'm doing here, I am trying to converting into this particular vapor type. From the vapor type, again, we are trying to converting into this particular example, primitive type here. So finally, it will return 200. Okay, so this is very important here. We are converting into vapor, and from the vapor, we are again converting into primitive type. Now you can see, whenever I'm trying to use this integer. So you can see from the 9 version onwards, it is deprecated. From this particular 9 version onwards, it is deprecated here. So how we can load this object information here? How we can load the object information here? So directly, is there any way to load this object information? That we need to understand. For example, instead of using this particular integer dot, so now you can see get integer is expecting string comma integer value. So value of, okay, value of method we are having, the value of method internally, it will return the integer object. So here I'm trying to pass value. So this is the another way of returning the integer object, because the object creation is deprecated. So we cannot call the constructor directly. So instead of calling the constructor directly, now what I'm doing is I'm calling the method here, the value of method. Okay, basically it is a static method. Now you can see, so it's trying to do some conditions here. Again, they are trying to use the same internally, but this is also deprecated internally. Okay, but explicitly this is not the good behavior to use the new operator here. This is not the good behavior to use the operation here. Okay, so this is all about the conversion. And tomorrow we'll try to understand the auto boxing here. This is also important example we are going to discuss tomorrow. Once we familiar with the auto boxing, we'll discuss about the annotations here. Okay, any questions regarding our today's session?
No, sir.
Thank you. So if you don't have anything, so we are going to close today's session and we'll continue tomorrow. So now tomorrow is also one of the important here. Basically, how we can convert one data type into another data type. The section we are going to discuss in the tomorrow session.
Thank you, sir.